What is voltage? Voltage is defined as the amount of potential energy between 2 points of a circuit, often referred to as electrical pressure or potential difference. The units of voltage is measured in volts or joules per coulomb, which is equivalent to energy per charge. A common analogy used to describe voltage is with two water tanks. As the water increases in one, the pressure will too, and when released, the water in the fuller tank will flow out at a faster rate. This is the same for voltage. As the voltage increases, so does the electrical pressure, and the electrons will flow faster through the circuit. Some formulas useful for calculating voltage and relating it to other concepts include Ohm's law, where V equals IR, V equals P over I, relating voltage to power, and V equals W on Q, relating it to work and charge. The voltage divider rule is useful in identifying a particular potential difference in a circuit, and it can only be used when components are in series. If the circuit has multiple branches, they will have equal voltages. Kirchhoff's voltage law, or KVL, is important in identifying that the sum of all voltage rises and drops around any closed loop in the circuit must equal zero. Now I'll go through some examples using some of these formulas for the circuit presented. To use the voltage divider rule, the resistance must first be found, equating to the sum of all resistors since they are in series, resulting in 1,000 ohms. Next, each value can be substituted into the above formula to produce all four of the voltages. To double-check these values, Kirchhoff's voltage law can be applied to ensure the closed circuit equated to zero. So, how does polarity affect voltage? Polarity, depicted by the plus and minus signs on either side of the 2 points, determines if the voltage is a rise or drop. This will decide whether each voltage is subtracted or added when using KVL. These images depict both an open and a closed circuit. When the circuit is open, no electrons will flow through the wire, and the entire voltage from the source is across the open part of the circuit. In the closed circuit, KVL can be applied, and the sum of all voltage rises and drops across the circuit is equivalent to the source voltage. So how is voltage measured? It can be measured using a voltmeter or a multimeter. The device must be connected in parallel to the component where the potential difference is being measured. Multimeters generally display more accurate readings as they can provide more decimal places, providing a more precise answer. So what's the importance of understanding voltage? Apparatus called transformers can be used to increase or decrease the voltage in an alternating current. When voltage is reduced, a step-down transformer is used, and for an increase, it is called a step-up. The purpose is to increase the efficiency when transmitting voltage and reduce power loss. This is a formula that can be used showing the proportional relationship between the number of turns and the voltage. Finally, it is important to understand the difference between voltage and electromotive force, or EMF. EMF is the total energy provided by a source, while voltage is the potential difference measured across any part of a circuit. In an open circuit, these values will be equivalent.